Hey everybody, this is Games Plus James, and today we're going to take a look at creating a 2.5D movement system in Unity. So we're going to create a system that uses a flat 2D character moving around in a 3D world, much in the same way that how it works in the Paper Mario games. So we've got this little character that can move and jump around and jump up in the air, and he can move backwards and forwards into the scene. And before we dive into the game, just a quick reminder that you can wishlist our game Skookaboom and the Tomb of Doom on Steam right now. You can see the game on the screen, and it really helps us out if you wishlist the game, and also obviously it lets you know when the game comes out and when there's a launch discount being applied during the little first launch period of the game. So go ahead and wishlist the game on Steam now, and we're going to dive in and start making this 2.5D movement system. Okay, so here in Unity we've got this start version of this project, very simply set up. You can download this and follow along with the project yourself as well, or of course you can use your own stuff, it doesn't really matter. I have this player set up that we're going to use. I'll just very quickly go through how this is originally set up. All it is if I go to my player here, I've got a sprite sheet of all these different things. I can drag one sprite into our scene, this is our player, and then I added a capsule collider to this player. So I will shrink down the radius of that, and I can adjust that to whatever way I want to. And then it also has a rigid body attached so that we can control it in the world and move it around, and it'll fall down to the ground all nice and simply. So I'm just going to remove this one from our scene, and I'm going to go look at my player here, and you'll see we have a capsule collider, a rigid body. We actually have this sprite as a child of the main object. You can see a sprite here. And I've got a couple of other things set up for this character just to speed things up a little bit so we don't have to see them as we go. One of which is a point at the bottom of the feet. This will be what we use to check if we're on the ground. And we also have this sphere here. This sphere, you can't see it in the scene view because it is currently hidden. And what all this is doing is providing a shadow for our player. So if I move the player up in the air, it basically gives us a little shadow mark on the ground. Very simple to do. All you have to do is go to the sphere here and switch these cast shadows here to shadows only. So if I just turn shadows off, you'll see this sphere reappears in our scene. But if I turn this to on or two-sided, whatever, you can see the sphere there. But if I turn it to shadows only, there we go. We get just the shadow below our player's feet. Okay, I've also got a couple of animations set up on this character. So the sprite has a few animations for movement, and I've one other flipping animation, but we'll discuss that as we go through the project. So what we're concerned about is making this move around and making it look good. So first thing we're going to need to do is create a script to move this player. So let's go into my folders. I have a scripts folder with a camera controller in it, and I'm going to go in here and create a new player controller script. We'll attach this to the player. Once it compiles into the system, there we go. Now I can add it onto the player here. And we'll open this up in Visual Studio. And in here, we're going to need a couple of references to start off with. So I want to move around using the rigid body system. So I'm going to create a public rigid body that I'll just call DRB for the rigid body. Then we're going to need two public floats, one for move speed, and one for the jump force. So that's going to be how fast we move around and how much we jump up into the air. And then I'm going to need a way to keep track of the input that I'm pressing. So I'm going to create a private vector2 that I'm going to call move input. Okay, so then down in my update, very simply to get our character moving around, I can say I'm going to set the move input dot x to be equal to the input.getAxis horizontal. So when we're moving side to side, we're going to use the horizontal input axis. And when we want to move forward or back in the world, we're going to use the move input.y equals to input.getAxis vertical, like so. Oh, I need to put my semicolon at the end. And just to make sure that this movement we can end up in a weird situation where if you move to the left, say, and you move up, that'll give us a movement too fast in a diagonal direction. So to smooth that out, we just say move input dot normalize. So basically it means you have a good range of motion, but you won't go too fast in any particular direction. Okay, so we're going to apply this then to our rigid body. And to do that, we're going to say the RB.velocity equals a new vector tree. And on the x-axis, we're going to say use the move input dot x multiplied by move speed. And then on the y-axis, rather than using move input dot y, because we're not moving, we don't want to move on the y-axis, because if we go back into Unity here and look at the player, if I drag this up on the y-axis, so if you see the numbers change here on the y-axis when I drag it up, that makes the player go up into the air. What we want instead is to move the player backwards using the z-axis. So if I drag this back like this, you can see the z-axis is changing, and that's the player moving back and forward in the world. So we want to apply the move input dot y to the z-axis, but obviously we have to deal with the y-axis first. So what do we want the y-axis to do? Well, we want it to maintain whatever velocity it currently has. So we'll just say keep it at the rigid body velocity y, and then we'll say move input dot y multiplied by move speed. Okay, so save this. Let's jump back in, and that should all work for us. So let's give him some movement stuff here. So I'm going to get this rigid body and drag that in there. There we go. Move speed of 10. And let's go with a jump force of 15. We haven't got any jumping working yet, obviously, but we have that in place. So now if I press play. Oh, I typed something wrong in the script here. Oh, there we go. I put an extra bracket in there. Whoops. Let's go back in here. And when I press play, there we go. Okay, so we can move the character around. Obviously, he's not animated at the moment. We'll deal with that shortly. But we've got the movement going. So now that we have movement going, the next thing we want to do is make our player jump. And to be able to jump, we're first going to detect if we're on the ground. So to detect if we're on the ground, we're going to do a raycast down to the ground. So we're going to check, hey, we're going to shoot a line down to the ground from a certain point, and if after a certain distance it hits the ground, so obviously a very short distance, we're going to say, hey, we're on the ground because the ray was able to hit the ground. So I'm going to first of all create a public layer mask called what is ground, and this will make sure that the ray can only hit a certain layer. So if I go back in here, my player is on the default layer, but this ground here, if I can select it, has the ground layer applied to it. So I want to check for anything that is the ground layer. So let's go back up here. Let's go back to our player. So we're going to set that up in a moment. Then we need to point from where our ray is going to shoot from, and that's going to be the ground point that I had in the inspector a few moments ago. So public transform ground point, we'll call it. And then we need to keep track of whether we're on the ground or not. So I'm going to say private bool is grounded. Okay, so let's just save this and set these up first of all, so that we know what they're doing. So we've got what is ground here. I'm going to set this to be ground. So we're doing a check for the ground. And then ground checkpoint, I'm going to slot into here. So this point in space here, which is just a little bit above the ground, as you can see, is at minus 0.75, whereas the player is 1 in the air. So it's 0.25 basically above the ground. So we're going to do a check from this, that we're going to make a check, say, about 0.3 in length, and make it shoot down to the ground and detect if we are on the ground. Okay, so let's go back in here then, and in our update loop, we're going to check if we're on the ground. And how we'll do that is by saying we're going to create a raycast hit called hit, and that's what will store the information about whether it hit any objects. And then we can do an if statement and just check if we do a physics dot raycast from the ground point dot position. We need to tell it what direction it goes in. So that's going to be vector tree dot down. So we're just shooting it down straight into the ground. We're going to say out hit, which means send the information from the raycast out into this object, basically. Then we're going to say how long we want it to be, and that's going to be 0.3, like I said, because that point is 0.25 above the ground. And then we need to check what are we trying to look for. Well, that's our what is ground variable. So that's how we do a very simple raycast. And basically, if this is true, so if it does the raycast and it finds something, then this will return true here. So we'll say is grounded equals true. else is grounded equals false. So it's either we're on the ground or we're not based on this raycast now. And with that information, then we can do a check and say if we do an input.get button down and we press the jump button and is grounded is true. So if we're on the ground and we press the jump button, then we need to shoot ourselves up in the air. And how we do that is just by saying the rigid body dot velocity plus equals a new vector tree. So we're just going to add on 0 on the x-axis, but we're going to add on the jump force on the y-axis and also 0 on the z-axis. Okay, save this and let's go back in here. Okay, we'll play now with that all set up, and I can move and I can jump. So I can't jump in the air, I can only jump when I'm on the ground. Okay, so we've got our character here, but of course at the moment we don't have any animations working. So let's go ahead and start making the animations work for us. So let's stop this running here. If I go to the animator I have set up, I make sure I have my sprite here selected, which has all the sprite animations attached. If I go to my animator, you can see I've got a few different animations set up, just the player idle, then the player running, player jumping, and we have the same for the player moving backwards. We'll deal with just the normal movements first of all, and then we'll get to the backward stuff. But up here we've got some variables for the move speed, as obviously how fast we're going, whether we're on the ground or not, and we have a moving backwards variable, which again, we'll deal with that in just a moment. But let's get our player animating his movement first of all. So let's go back into our script. We'll obviously need a reference to that animator. So let's say public animator that I'm just going to call anim. And then after we jump down here, I'm going to say anim.setBool on ground to be is grounded. So on ground is the value I have here for determining whether we're on the ground in the animator. And let's just test that out. So I'm going to save this, go back in, and once that compiles, I can press play. And our player, when they jump in the air, oh wait, no, I didn't assign the animator. Let's go to our player here and drag the sprite into there, which has the animator attached. So now if I go ahead and press play, this time if I jump, there we go, it switches to the jump animation. So let's make the walking animation work next. And for this, we're going to say, we'll put this after the movement code is applied up here. So we're going to say anim.setFloat for move speed. And because we're moving on both an X and a Z axis, so we're moving side to side and also forward and backward in our scene, rather than just using whatever the x-axis value is or the z-axis value, what we're actually going to use is something called the rigid body dot velocity dot magnitude. So magnitude basically tells us how fast the rigid body is moving, and we essentially want to know that just so we know that we're either at 0 or we're moving at whatever speed we have in the game. So I can save this. Now that we have move speed being sent out there, I can go back in here. Let's turn on maximize here. And when I play, there we go. Now we have our character moving around. But the first thing we'll notice is that when we move to the left, our character still looks like they're facing to the right. So let's fix that. We want to be able to flip how our character is facing. And a very simple way to do that is on the sprite object here, just to turn flip X on and off. Very easy to do. So let's do that in our script then. So to do that, we'll obviously need a reference to the sprite renderer. So we're going to up here say public sprite renderer that we'll call the SR. And then we're going to scroll down to here and we're just going to do a simple check. What we'll do is see, first of all, I'm going to check if we are not already flipped. So if the sprite renderer not flip X, so sorry, if not the sprite renderer.flipX. So if we're not already flipped and our move input dot X is less than 0. So basically, if we're not flipped and we start moving in the left direction, well then we need to flip the value. So the sr.flipX equals true. Else, if we are flipped, so the sr.flipx, so if we're already facing to the left and our move input now is greater than 0, so we start pressing to the right, well, in that case, then the sprite renderer dot flipx, there we go, should be equal to false. So again, let's save this. We'll go back in and see this in action. We should see our character moving around a little bit better now. So we'll play, we'll jump. Nope, we didn't attach the sprite renderer. So let's go to my player, sprite renderer, there we go. So if I go ahead and play again, there we go. Okay, so we're moving left to right. That looks a little bit better, but we still don't have forward and backward movement. Now, to be honest, like having movement like this wouldn't be the craziest thing. You see this in lots of games in general, but specifically in the Paper Mario games, we do get a backwards looking movement. So let's set that to working. Like I said before, I do have an animation already set up for this. If we go to player run backwards, for example, if I play this, there we go, we have it walking backwards. So let's go and make that happen now. So back in our script, first thing we're going to need is a value to store whether we're moving backwards or not. So I'm going to have a private bool moving backwards, and then we'll scroll down, and after this bit I'm going to do a check and see, okay, if we're not already moving backwards, and similar to what we did with the flipping, and we do move input dot y is greater than 0, so we're moving backwards in the scene, well then moving backwards equals true. And then we'll do another else if we are moving backwards already and our move input dot y is less than 0. In that case, then we are moving forward, so moving backwards equals false. So we're moving forwards into the scene, and then we need to send this information. We need to send this information out to the animator. And if we go look at our animator, I have a moving backwards value set up here, which is just be either true or false, and that will make us switch to these animations in that situation. So what I need to do then is, just after we have set whether it's true or false, we'll tell the animator to set the bool value of moving backwards to be whatever the moving backwards value is. Okay, so save this. Very, very simple, as you can see. I can go back in, let this compile. And now when I press play, we should see when I walk forward is fine, and when I walk backwards, there we go, we can see our player moving around correctly. Okay, so that's most of the basics of this system working. But one really cool and interesting thing that the Paper Mario games do is that when you change direction or when you start moving back and forward or anything like that, the character flips around in the game. So the sprite kind of spins around on itself. So we can do that very, very simply. So I'm going to stop this running here. So we had all these animations on the sprite object of our player. So we had the sprite renderer here. And then on the player object here, I have another animator set up that just has two animations. I have player static and player flip. So player static is obviously just the normal animation of our character here. Or sorry, the normal no animation is happening. Our player is just staying still. But if I switch to player, sorry, that's player static. If I'm on player static, there we go, there's no animation. But if I go to player flip here, if I just play this, you can see this is just an animation that spins the character around. So what we want to do is make this animation play essentially any time that we switch directions or start moving backwards or forwards. So it's a very, very simple thing to do. And an example of how you don't have to control everything through code. Sometimes it's better to use animators to control this kind of stuff. So what I've done then in the animator over here is just set up a trigger value that will make it go at any time to the player flip animation. So we have our flip trigger here. So let's make that flip trigger be activated. And if we go back into our script here, we're going to need a reference to that animator, because obviously this is not just the same animator we have here. So we're going to have a public animator again called flip anim. And then we need to set this to happen whenever we change direction or start moving backwards. So we already know that this is what we're using to flip when we change direction. So in here, we can say whenever we're changing the flip value, we can also say on the flip animator dot set trigger, the trigger we want to set is, I need to check the name of this back in here, is just flip. There we go, with a capital F. So we're going to set the flip trigger to activate. So I'm going to copy this then. This is obviously going to happen also when we set the flip X to be false. And then we also want this to happen whenever we start moving backwards or forwards in our scene. So whenever I set the moving backwards value, I'm going to apply it here. So we'll save this and let's go back into Unity. And we're going to let that compile, and there we go. Okay, so I'll switch over to my game view here. And I'm going to make sure I hook that up on my player. So I'm going to drag this animator into the flip anim slot. And I'm going to go ahead and press play. And now, whenever I flip around, we get this nice spinning animation. And obviously, if you find that the spin is a little bit slow for you or a little bit fast or whatever, you can go ahead and adjust the animation. So very simply, I could go to the animation here for the player flip. You can see at the moment it takes this whole length of time, and I could shorten this down a good bit. So I could go wee like this. And now, if I do this again, our flip is a little bit faster. But I personally like it at this kind of length. Obviously I set it up this way, so this is the length I like it at. So I can go ahead and play, and we've got this cool little flipping effect whenever we change our directions. And there you go. That's it. That's how we can create the Paper Mario style of 2.5D movement in Unity. It's a lot of fun to do, and it actually feels quite a lot of fun to play. I kind of wish this environment had some collisions attached to it so I could navigate around it a little bit more, but that's okay. It's a pretty cool environment that is available for free from the asset store, and obviously we're using some Kenny assets for the characters as well, customized a little bit. But there we go. Very easy to do and absolutely worth trying out for yourself and trying out just to see how fun it can be. So thanks for watching this video. Don't forget to go and wishlist Scoot Kaboom on Steam. Again, the link is down in the description down below, and you can check that out and be super awesome. I'll be back soon with more tutorial goodness. Keep being awesome, keep making amazing games, and most importantly, keep sharing them here on the channel and on our community Discord group that you can find, again, linked in the description down below. So keep being awesome, and I'll see you all very soon.